All right, so let's go over the first example. Right, the first example. This is these are two masses A and B. They are like moving towards each other. One mass A is moving to the right with 10 meter per second. Mass B is moving to the left with 5 meter per second. And there's going to be an impact at some point when they reach to some point. They get together, and there's going to be an impact. And we want to study this impact. Right? So the example statement, pretty I think in this case is straightforward. We have uh, these two masses, mass A and mass B, each is 4 kilograms. So write it this way: the 4 kilogram masses A and B, each is 4 kilogram. They slide. So we're told that they're sliding on a smooth horizontal bar. So there is no friction involved. A slide on a smooth horizontal bar, right, with the velocities shown, with the velocities shown. Right? We want to find the velocities after the impact. Right? That's a very straightforward question, I would say, that we have to address. So find their velocities after they collide. Right? And also we are given the if their coefficient of restitution is 0.8. Right? So E is also given. Now, this is outcome 2, case 1. Right? We have direct central impact. Two objects, they are traveling along the same straight line, right? Same straight line. We know their velocities before impact. We know the coefficient of restitution between these two for this impact. We want to find out what are their velocities after the impact. So we have two equations. We are looking for two unknowns. Pretty straightforward. We just write down those equations. Let's start with the first one. Right, MAVA plus MBVB is equal to MAVA prime plus MBVB prime. And remember, velocities, you have to take one direction as positive. So let's say take this as positive, and if I do that, then VA becomes 10 meter per second, and VB becomes minus 5 meter per second. These are vectors, so they have magnitude and direction. Take one side as positive. This is just on the same line, so you don't even need to come up with a coordinate system. As long as you take one side as positive, we can represent everything in a vector form, like magnitude and direction. So we had MAVA plus MBVB is equal to MAVA prime plus MBVB prime. All right, and plug in the values. You have M 4 kilograms. Even if you were not given the value for mass, you would have been fine here because they have the same mass. But let's just plug in everything. So 4 times VA is 10 meter per second plus MB4 times VB, which is minus 5, is equal to MA4 VA prime, which we don't know what it is, all right, plus 4 VB prime. So VA prime plus VB prime becomes 5. Right? This is equation 1. This is the first equation. I have two unknowns, VA prime and VB prime. Right? We'll go for the second equation. Right? E is equal to V prime minus VA prime over VA minus VB. So E is the first equation. Second equation, E is equal to VB prime minus VA prime over VA minus VB. Right, as I said, these are vectors. Right, let me put these vector signs just to remember. Now, these are vectors, and we derived, or we wrote this equation for the case where VA, VB, VA prime, and VB prime, all four velocities were positive. Now, this case, well, VA is 10, VB is minus 5. So when we plug in these values, you have to be mindful, and you have to remember that VB is negative. That's the main reason I brought this example. I wanted you to emphasize, I want to emphasize that these are vectors, directions matter. And remember the directions that we assumed when we wrote those equations, right? Those are these the positive directions. Whatever changes, you have to take that into account. So VB prime, well, we don't know what that is. Oh, that's something we want to find. VB prime minus VA prime is over. VA is 10, VB is minus 5. So minus 5. And this is equal to 0.8. Right? Then if you simplify this, we'll get you VB prime minus VA prime equal to, you will get 12 meter per second. This is meter per second. This is equation 2. So you have two equations, two unknowns to solve for those two unknowns. 1 and 2 will give you VA prime and VB prime. Velocity of object A after impact, velocity of object B after impact. Velocity of the object A after impact turns out to be minus 3.5 meter per second, and velocity of object B after impact is 8.5 meter per second. Right? These are what we were looking for. Pay attention that now VA prime became negative, which means after this impact, right, VA is going to the right, VB is going to the left. Impact happens. After the impact, VA goes to the left, right, goes back to the left with 3.5 meter per second, and VB goes to the right, with 8.5 meter per second. So now you can see the dynamics of the impact. They're going this direction, impact happens. After the impact, these are the velocities. With these velocities, they go in opposite directions, right?